Okay, so lesson number 3, elimination. Probably the most widely used of all the solving I was gonna say simultaneous there. Okay, all right. Solving all of your systems of equations, sometimes called simultaneous equations, but we're just gonna stick with vocabulary here. So yeah, and the idea of elimination is we got to make sure things are aligned. So we're always gonna have this in standard form. Remember, that's the x, the y, the equals, and then the number that's there. And that aligns your variables. The x is on top of the x's, the y is on top of the y's, the numbers on top of the numbers. And then, like it says, eliminate. All right. And so when we eliminate something, it's gone. All right. And then we always like to use addition when we do that. So we'll kind of talk about it because when we involve subtraction, it gets a little bit messy. So let's go through the absolute basic here. And that's question number 1. So we can see we are aligned. X is on top of x's, y is on top of y's, numbers on top of numbers. So we can actually just straight up add. And the reason why is when we add right away, we eliminate a variable. What's negative 4x plus 4x? 0. So the x's are gone. We can just add away here. We've got a negative 2y. We've got a positive 2. Divide both sides by negative 2. And yep, y equals negative 1. There we go. Doesn't matter whether you solve for x first or for y first, as long as you're solving for one of them by eliminating the other. So now I can just reach for one of my original equations. I can plug in the y equals negative 1. And we can just solve. So I'm just going to grab the top one. All right. So it's a negative 4x plus 3. And it's times negative 1 because, again, y was negative 1. So negative 4x minus 3 equals negative 3. Let's add 3 to both sides. Negative 4x equals 0. Remember, it's okay to have a 0. We get into no solutions and infinite solutions when the letters go away. So you see, like we still have an x that's there. Yeah, so that's okay. And yeah, x equals 0 because 0 divided by negative 4 is 0. So yep, there's my ordered pair, 0, comma, negative 1. Now, again, if I'm uncertain about this, I can plug it back into my original 2 equations. And when I plug in that 0 for x and the 0 for negative 1, we will get true statements. Again, the check step is optional. It's more of a safety net that's there. Okay. All right. Question number 2. We're not aligned. All right. Do you see how the y and the x are above each other? Yeah. So we're gonna rewrite this into standard form. So the bottom one's already in standard form. 3x minus 4y equals 14. We're okay there. But because we're on the same side, we just have to move things. So it's a positive 3x, so there's a 3x. And it's a positive 4y, so we're going to add the 4y and then equals the 22. Okay. So again, right away here, we can just add. All right. We can just flat out add because that'll knock out the y's. 4 plus a negative 4, gone. So yeah, so I've got a 6x that's here. All right. When I add these together, I get a 36. Divide both sides by 6. Yep, x equals 6. And again, we just grab one of the original equations. So I'll just grab it because it's right here, and I'll plug that on in. So that's a 3 times 6, and then minus 4y equals 14. Remember, when you substitute, it's just for the one piece, and everyone else just comes along for the ride. So 18 minus 4y equals 14. Let's subtract 18 from both sides. All right, yep, good old-fashioned algebra here of solving equations. Equals a negative 4. Divide both sides by negative 4, and yeah, we get y equals 1. So there we go. So again, we can say this, that's fine, or we can write it out as our ordered pairs as well. So again, either way gets the job done. All right, so there we go. So just straight adding, all right, because things are already set up for us. Or we might have to do a little rewriting and then look for it. So you know what's coming next here now. What happens when we just can't add right away? All right, so I'm going to go after problem number 3 here. And in problem number 3, if I just add, I get a 9x. And if I add the y's, I get a 2y. That did not eliminate anyone. So we're going to multiply in order to eliminate. Now, the rule is as long as you multiply everyone by the same person in an equation, it's legal, that's there. So I'm looking at the 2 and I'm looking at the 7. And I'm actually going to stay away from it because there's nothing I can multiply a 2 by to get to a 7. So I'm going to check the y's. And yeah, I got a negative 1y. Is there anything I can multiply that negative 1 by to get to the 3? Yes, we can multiply it by 3. Now, things we want to keep in mind. We always want opposite signs because when we add opposites together, we get 0, and that's when the elimination happens. So in this particular case, I'm going to multiply everyone up here by 3. I'm just going to tuck it below it there. So 3 times 2x, well, that's a 6x. 3 times negative 1y, that's a negative 3y. 3 times 4, that's a 12. So remember, if you multiply an entire equation by the same person, it's completely street legal. All right, now I'm focusing on these two, and now we're back in the original situation. If I add, they're gone. So I get a 13x equals, if I add the 27 with the 19, I get 39. Hey, look at that. I was nervous about the 13, but yep, divide it. We get a crisp clean 3. All right. Again, I like to go to one of the original equations. So I know I rewrote the 6x minus the 3y. I like to go back to the original problem there. So I'm just going to grab the first one because it's got less writing with it. Again, I could grab the other one. We'd still get the same answer when we solve it. But yep, let's plug it in. So yeah, 2 times 3 is a 6. So again, because we can kind of do that in our heads, it's kind of, we can move a little bit faster with it. Subtract the 6 from both sides. Negative y equals negative 2. So y ends up equaling 2. So when we write it out, yep, we got the ordered pair, 3, 2. And we're set. All right, that's a bad looking 2. Sorry, 2, didn't mean to call you out like that. There we go, that's better. All right. So again, sometimes we need to multiply a row in order to do our elimination. So let's just look at problem number 4 here. In this case, I'm going to focus on the x's. And I'm going to focus on this bottom row because I can multiply the 1 for the 2. Now remember, we always want different signs though. So if I just choose a 2, it's not going to eliminate anyone because when I do 2x plus 2x, we get the 4x. And you might be like, well, let's just do subtraction. You could. Subtraction gets messy further down the road. So what you're typically going to end up seeing here is, let's just not multiply everyone by a 2. Let's multiply everyone by a negative 2. So that gives me a negative 2x, a minus 10y, and a negative 4. So I'm just going to drag it over. There's my 2x plus my 7y, and then equals my 1. Now we are ready again to do our elimination. Because when I add nighty-night, the x's are gone. Hey, I get a negative 3y. I get a negative 3. All right. Hey, we're getting some nice. Now, again, we're not always going to get crisp and clean. Okay. It's not going to happen. But because we're just learning, we try to keep it friendly for you guys. So yeah, grab one of the original equations. I'm just going to grab this top one because I can see it best. So 2x plus 7 times 1, because remember, we're substituting the 1 in for the y. That's a 7. And we can solve. Subtract 7, 2x equals negative 6. Divide by 2, and yep, x equals negative 3. So, yep, write out my ordered pair, negative 3, 1. And we are set. So, yeah, I mean, the idea behind this is that you need to eliminate. And some of you will choose maybe like, well, couldn't I do this instead? You can. There's just, like I said, it's different ways of solving it. It's the whole simplifying and the solving. It's all going to match up regarding it. Okay, so we're going to show you someone else here. We're going to go after question number 5. Okay. Now, the reason why we're going after question number 5 is it's not just going to be a 1 multiplication thing. You see, I'm looking at the x's. Is there anything I can multiply the 2 by to get to the 3? No. I'm looking at the other equation. Is there anything I can multiply the 3 by to get to the 4? No. So we're going to have to multiply both rows by something. Now, again, I can play with the x's. I can play with the y's. I'm just going to play with the x's there first. So what's a number that 4 and 3 can both fit into? Well, 12, all right? So the idea is I'm going to multiply everyone here by a negative 3. And the mindset is that'll give me a negative 12x. Well, if I look at the next one, oh, let's just finish it. Negative 6y, all right, equals negative 24. All right, now, again, I want the 12. Remember, I'm going to choose, though, just a plain old 4 here because that gives me a positive 12x. So again, what I notice here now is I've got my opposites. So you might have been like, well, wait a second, why not multiply the top by 3 and the bottom by negative 4? Okay, it's not going to make a difference here. When we eliminate, we're still going to get rid of the x's. The signs will still take care of each other. So don't panic regarding that. Okay, there's my 12x, there's my 12y, and there's my 36. So yeah, now we can add 90 nights, eliminated. There's a 6y, there's a 12. Yep, divide by 6, y equals 2. Again, I find this technique much more efficient than substitution. Substitution seems like it's much more drawn out. There's a lot more to do regarding simplifying. And then graphing, it's just kind of, okay, slope-intercept form, but then we don't know if it's going to fit nicely on the graph. So that's the hesitation behind it. Okay, but let's finish it off. I'm just going to grab one of the originals. I'll grab the first one I see here. So that's 3x plus 3 times 2. So that's a 6. Yep, I can subtract 6 from both sides. 3x equals 3. Yep, x equals 1. So I've got the order pair 1, 2. That's it. Now, again, check step. I could plug in my x is 1, my y is 2. 4 times 1 is 4. 2 times 2 is 4. Is 4 plus 4 equal to 8? Yes, it is. All right, check the other one. 3 times 1 is 3. 3 times 2 is 6. Is 3 plus 6 equal to 9? It is. So again, that is your check step, not required by law, but just in case you're a little bit nervous regarding it, we've got you taken care of. All right. So again, we see the beginnings where we were given opposites, and we can just, boom, add them right away to eliminate. And then we run into the ones where it's like, oh, wait a second, I need to multiply you by someone in order to eliminate. And sometimes it's just one row that's there. And then we saw in the very last setting that's there is the fact of, hey, listen, I multiply by one row, I still can't eliminate. You're going to need to multiply both rows by someone. So those are your 3 different styles. Real quick, take a look at question number 6. Multiply, right? Right? You're going to have to multiply both rows by something. No. Oh, people, we started. I got to finish this here. Watch what happens. Multiply by 2. All right. I get a negative 10x. I get a 8y. I get a 40. All right. Now, ooh, look at this. Everything eliminates. All right. 0, 0, 0. Is 0 plus 0 equal to 0? Yes, it is. True statement. So because it's true, we say infinite solutions. All right. Sorry, I couldn't resist. That's there. So again, that one, I just had to multiply by 1 in order to get elimination, and it just happened that the other one's eliminated as well. So, whew, lots of little variations. But again, the goal always, every single time, is to eliminate one of your variables. All right, we're out of here.